So let's look at this first phenomenon of harmonic distortion that arises due to non-linearities in amplifiers. For that, let's consider a certain amplifier where you have a input voltage which is having A cosine omega t, A being the amplitude, omega being 2 pi f being the frequency, angular frequency. And for example, let's consider this amplifier to have third order nonlinearity. That means it's going to have, the output is going to be beta 1 times the input. Output is going to be beta 1 V in plus beta 2 V in squared plus beta 3 V in cube. But when V in is of the nature of cosine, then we notice that the cosine squared and the cosine cube terms can be expanded by the trigonometric properties of cos 2 theta is 1 by 2 1 plus, rather cos square theta is 1 plus cos 2 theta. So such trigonometric identities can be used to reduce the to simplify the square term, the cube terms in terms of cosines, and we would notice that the output is distinctively having 4 different terms here. The first term, if you notice, does not depend with time. It does not depend with time, and such a term is going to be the DC term. So such a term is going to be the DC term. The second term, which is cosine omega t, which is the same as the frequency of the input, is called as the fundamental. What is interesting is the third term, which is going to be 2 omega t. The frequency of the fundamental is going to be 2 pi f, omega is going to be 2 pi f. In this case, the frequency is going to be 2f, leading to 2 omega here. Similarly, the third harmonic is going to have 3 omega, meaning its frequency is going to be 3 times f. So you would notice that with a single input of frequency f, that is leading to a frequency of 0, f, 2f and 3f when we have what is called as the third order nonlinearity. So if there are higher order nonlinearities, there are going to be many other harmonic frequencies. In general, the nth harmonic will have n times the fundamental frequency. Why is this a concern? Maybe there could be a situation where, let's say, the 2G telephony was using 0.9 gigahertz, 900 megahertz spectrum for the transmission. Every integer multiple of this is going to be a harmonic frequency. Every integer multiple of the fundamental. So 0.9, the next multiple is 1.8, which is again was used in the GSM standard for cellular technology. The third harmonic is going to be 2.7. So the fourth harmonic is 3.6, fifth and the sixth harmonic lies very close to the wireless LAN, the 5 gigahertz wireless LAN 802.11 standard operating frequency. So this harmonic distortion, rather than f in the input leading to the same frequency of f at the output of the amplifier, instead of this is in the case of an ideal, but because of nonlinearities, the input f is leading to a whole bunch of frequencies which are harmonics of the fundamental, and that is what we call as the harmonic distortion.